Hello everyone, and welcome back to another GIS lecture video. In this lecture video, I want to wrap up this week's discussion by talking about a different way that we can measure the distance between two locations. In specific, I want to talk about something called Great Circle Distance. So, Great Circle Distance takes in inputs of latitude and longitude, to measure distance along an arc across the surface of a sphere. Right, and so the key things we need to pay attention to here are latitude and longitude, because we're not working with x and y anymore, arc, and then surface of a sphere. So this measurement takes into account not just the x and y, but also the fact that the distance between them has to go along the surface of the Earth, which has curvature to it. So the explanation for how to derive this equation is a lot more complicated than we're going to get into here. But what I want to do is I want to talk through the equation, break down the different parts so that you understand what's going on, and then walk through an example calculation. So just like before, I'm going to call the distance that we're going to calculate d. We have 2, which is a constant, r, and anytime you have numbers and letters next to each other, we're implying there's multiplication there. And then we have inverse sine, so that's sine with a -1, of the square root of sine squared delta phi over 2 plus the cosine of phi a times the cosine of phi b times sine squared delta lambda over 2. And again, that's all under the square root. So there's a lot of symbols here. There's a lot to break down. So let's go ahead and talk through the things. So the first thing we have to remember is that we have the location A with its associated latitude phi a and longitude lambda a. And again, phi and lambda are the sort of equation designators for latitude and longitude. And then we also have location B with its associated phi b and lambda b as well. Right. So let's go ahead and break down the different pieces of this equation. So first we have r. This is the radius of the Earth. And in most cases, r is going to be equal to 6,378 kilometers. Right. Next up, we have this delta phi, which is the difference in phi, let's try and make that a little cleaner, difference in phi, or the words a minus b. And let's go ahead and actually define that as its own equation just to separate out some of the stuff here, right? So delta phi is going to be equal to phi a minus phi b, right? And by that same logic, right, delta lambda, this is the difference in longitude, right? And that's equal to a minus b as well. So if we define that by its own equation, right, again, right, delta lambda is equal to lambda a minus lambda b. And then all the rest of these are just various trigonometric functions, which we will walk through one by one as we go through the example. So let's go ahead and do an example of going from New York to Washington, D.C. So New York to D.C. Right, and we'll give New York a phi of 40.71 and a lambda of 74.01 west and north. Keep in mind I'm using decimal degrees here. And then DC, we will give a phi of 38.91 degrees north and a lambda of 77.04 degrees west. So the first thing that we want to do is we want to calculate delta phi. So delta phi is going to be a minus b. So that's going to be delta phi equals, right, again, I'm pulling this equation here. So plugging in phi a, which is 40.71. And I'm subtracting phi b, which is 38.91. Right, and if we do that equation and we do the math on that, right, what we get is 1.8 degrees. Right, so our delta phi is 1.8 degrees. So let's go ahead and work on this part here, the sine squared delta phi over 2. So sine squared delta phi over 2, right? So that's the same as saying sine squared of 1.8 over 2, which is the same as sine squared of 0.9 over 2, which is the same as or sorry, not 0.9 over 2, 0.9. Remove that, sine squared of 0.9. Now, if you've never seen the sine squared before, this is the exact same as taking the sine of 0.9 and squaring it, which algebraically is the same as saying the sine of 0.9 times the sine of 0.9. Now, I do want to take a second here and show you how to do this with the Windows calculator. So if you go to the Windows button and you open up the calculator, you should see something that looks like this. So what we're going to do is we're going to type in 0.9, so I'm going to click everything. Click the trigonometry button, click sine, and you'll see that we get a value of 0.0157. So I'm going to go ahead and I'm going to write that down here. 0.0157 approximately, right? And if we multiply that by itself, right, if we square that, so to do that, we would click the squared button. We get 2.467 e to the negative 4, right? 2.467 e to the negative 4. Now, if you've never seen e's or anything like that on a calculator, this is just the same as saying times 10 to the negative 4. Right, so what this is 0.1, 2, 3, 4, 4, 6, 7. Right, this is the same as this. These two things are equivalent. So that's the sine squared delta phi over 2. So let's go ahead and look at the delta lambda. So again, we're going to be pulling this delta lambda equation down here. Let's take a look at delta lambda. Right. So delta lambda is going to be lambda A minus lambda B. So in this case, it's going to be, all right, because both of these are west. Remember, when we're measuring west of the prime meridian, everything is negative. So this is going to be negative 74.01 minus negative 77.04. Right, and so again, basic arithmetic, right? A negative minus a negative becomes a positive. So this is going to become 3.03 degrees. Right, and so again, right, sine squared, right, delta lambda over 2 is going to be the same as sine squared 3.03 over 2, which is the same as sine squared 1.51. And again, we can do the exact same thing here. We can go back to our calculator here, and we can type in 1.51, 1.51, right? Trigonometry, if we take the sine of 1.51, we get 0.026. And again, because it's sine squared, we simply square that result. So we get 6.944 times 10 times e to the negative 4. Right, so that's 6.944 e to the negative 4. And again, e to the negative 4 here means the exact same thing, times 10 to the negative 4, or just move this over 4 times. Okay? Now, those are the hard parts. We've taken care of the sine squared. We've taken care of this sine squared. Now we just have the cosine of A and the cosine of B. So the cosine of phi A is going to be the cosine of 40.71, right? And so if we go into here, 40.71, 40.71, right? Trigonometry cosine is 0.758. right? Cosine of theta b, of phi b, right? That's the cosine of the phi of b, which is 38.91, which if we do that, go back to our calculator, right? 38.91. Again, click trigonometry, click cosine, it's 0.778. Okay, so we've done everything inside of that original square root. So putting all of this together, we have, so right now with the pieces we have 2r inverse sine, which we'll talk about in a minute, of the square root of 2.467 e to the negative 4 plus 0.758 times 0.778 times 6.994 e negative 4. Okay, so this is where we stand right now. We have the capacity to simplify or calculate everything under the square root right now. So what we're going to do is we're going to pull out our calculator. And we're going to do 6.994. Actually, you know what? To keep things simple, we're going to convert everything. So 1, 2, 3, 4, 994. So that's the 6.994 e to the negative 4. Multiply that by 0.778. Multiply that by 0.758. And if we do all of that, we get that value there. And then if we add to that the point 1, 2, 3, 4, 2, 6, right? That was the value of the sine of the delta phi. So if we add that, right, we get a value of 6.59 e to the negative 4. Right? So this is 2r sine negative 1 square root of 6.9 if we go back here, 59 e to the negative 4. So if we take the square root of that value, again, clicking square root there, we get 0.0257. So this is 2r sine negative 1 of 0.20257. Okay. Now the equation looks far, far, far easier to handle. We have this 2, we have this r, which we know is the radius of the Earth, and then we have this inverse sine thing. So what does inverse sine do? Inverse sine takes in this value and it spits out a measurement in radians. So this is going to give us basically the distance that we need to calculate the arc length along, or the length along an arc. So what we're going to do is we're going to take the inverse sine. So to do that, we're going to go into here. This is the value that we already had. To get the inverse sine, you're going to click on the trigonometry button, you're going to click the second button, and you'll see that it pops up sine -1. If we click that, you'll see that it took the sine here to the -1, so this is the inverse sine, 1.47. So this gives us 2 times r times 1.47. I'm sorry, we actually have to switch that to radians. I apologize. It expects the input to be in radians. So let's do that calculation again. 0. You know what? Actually, I want to make a bigger point of this. So this value, when you run this equation, I'm going to make a big square dealio here. Right? Make sure your calculator is in radians, because you see I just made that mistake and almost continued with it, right? So to do that on the Windows calculator where it says deg, make sure it says rad, and you can click this to change between them. Gradients, which we're not going to worry about, degrees for most of the calculation, and then this last piece you want to make sure you are in radians. So what we're going to do is we are going to go back in our history and we're going to take our value of 0.0275. Now that we are in radians, if we click trigonometry, second inverse sine, we get basically the exact same value back. Now that is a coincidence based on this example. That is not always going to be the case. So what we get is we don't get that bad. We get a value of 0.0275 or 0.257. And I'm going to make a note here in a different color. Right. These are not the same number. It just so happens that the inverse sine of this number is basically itself to within millionths of a decimal place, right? So now what we have left is 2 times the radius of the Earth is that 6,378. And the inverse sine we said was 0.0257. And if we calculate that out, again, we can pull up our calculator here. Right, 2 times 0.275 times 6,378 gives us a value of 3,508 kilometers. Right, and if you pull up Google, you can confirm that this is indeed the right answer. So I know there was a lot here. I encourage you to rewatch the video if you don't understand. But generally speaking, what we're doing is we're calculating the distance between 2 points on the surface of a sphere using latitude and longitude. It involves taking the differences in their longitudes, the differences in their latitudes, the cosines of both of their latitudes, and it includes the radius of the Earth, or the circle, which in this case is the Earth. So hopefully this all made sense. Again, rewatch the video on the parts if you're confused. And as always, if you have any questions, please reach out. Thank you.